Hello everyone, welcome to this tutorial. My name is Emerson Ahrari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to produce correlation map in the Earth Engine environment and Python programming language. So as you can see here, I will show you how to produce a correlation map between two variables and time series data. For example, here I'm going to use correlation map or produce correlation map between precipitation and temperature data. You will learn how to plot annual temperature and annual precipitation data for your region of interest. This tutorial can be used for all around the world. The satellite data, platform, and everything is free of charge, and you can use this tutorial for your own region and your own investigation. That could be very beneficial for you to learn about Earth Engine data analysis using Python API programming. Okay, let's go to a new Colab environment and start coding from scratch. I will show you how to do these steps easily and without any challenge. If you faced with any challenge during programming, you can find the code link below this video on actually description box. So let's get started first. In the first step, we want to call desired libraries that is necessary to make a connection between Colab and Earth Engine environment. Import Earth Engine library and import xarray as xr. In the next step, let's install a new library as xee and import it the xee. As you can see in the right panel, the xee is a library that integrates xarray and Google Earth Engine platform, and you can convert image collection to the array structure. That is very beneficial for applying machine learning and statistical analysis on satellite data. So xee installing and importing into the code. Make a new cell. In the next step, we want to make a bridge between Earth Engine and Colab environment through the EE library. First start with authentication and then initialization. So the project name refers to the project name you have in the cloud environment. Let's go to the code editor environment. In the upper right side here, you can see your account information. Just go to the project information, and here is your cloud project name. For me is like that, and then you must copy and paste yours into the project. So the next argument here according to xee instruction is opturl. Select, copy, and paste. There it is. Let's run a code, and then a new message popped up that asking you to grant a permission to connect to the code editor environment according to the project info you already provided. Now the connection is made, and now you can use Earth Engine script in the Python environment. So in the first step here, I'm gonna call Terra Climate dataset. So to find the image collection and data characteristic, open a new page and type Terra Climate dataset in the Google Earth Engine platform. As you can see, the first link is about the Terra Climate. It is a monthly climate dataset available since 1950s until the late of 2023 with 5 km spatial resolution, and here the variables are listed with their characteristic. So I'm gonna call the precipitation data and the temperature But as you can see, the temperature actually briefly available as minimum and maximum value in each mount with a scale factor. But for the precipitation, we have no scale factor values. So let's call the image collection through the collection snippet. Just copy and paste it into a new variable as collection. Then filter the data for a period of time, for example from 2010 to 2020. For 10 years, I'm gonna do actually the time series analysis first and then calculate the correlation map based on the time series data. Select the target band here. The first band is precipitation, temperature min, and temperature max are my targets here. So temperature min and temperature max. Temperature, sorry for a moment, I have a problem about my keyboard and I'm trying to fix it. Just a moment. Okay, now I can continue coding in the Colab environment. The second temperature band was temperature max that is selected. Let's run a cell and then make a new one. Through a ds variable, I'm gonna convert the collection format to the array structure. So now from X array XR, let's call open dataset here and bring the collection inside the dataset according to EE engine. So the CRS, you must define the coordinate system, spatial resolution, and region of interest here. CRS equals to WGS84 through this code EPSG4326. This is unique for all around the world. And then we will have the scale factor, the scale or spatial resolution or correct pixel size. The resolution is around 5 kilometer and you should enter the resolution according to degree unit. So 1 degree 100 kilometer and 5 kilometer equals to 0.05. There it is. The next is about the geometry or the region of interest. It is better to define your region of interest through the coordinates for region of interest. To find the coordinate of your region, let's go to the code editor environment. For example, in this tutorial, Iran is my region of interest and you must define upper left and lower right coordinate for the region of interest. So you need 2 points in this regard. 2 points selected and then you can see the values of 2 points in the code editor environment. Then make a new variable, for example location, and then you must enter coordinates for the region like this format. First bring the minimum longitude in these 2 points. Minimum longitude first, then minimum latitude, then the maximum longitude, here it is 66, and the maximum latitude 39. So these are rectangle address for the region of interest. Copy and paste it into the code in the Colab environment. Geometry equals to the location and then run the dataset. So now the dataset is created. Our image collection converted to array structure. Let's get a print from dataset After a few moments, you will have a multi-dimensional data. One dimension time and another one is longitude and latitude. This is a monthly data available since 2010 to 2020 with three variables: precipitation and temperature max and temperature min. In the next step, I'm going to show you how to convert or how to produce this data to annual temperature and annual precipitation, how to visualize it, and how to make correlation map. Let's get started with the precipitation data. So the annual precipitation, PR annual, equals to, from DS select the PR variable as you can see, and then resample to yearly frequency. Time equals to yearly, and for each year when you are dealing with precipitation data, to convert it to for an annual precipitation, you must get the sum of the precipitation in each pixel dot sum. So sum, we want to get sum of the precipitation per pixel for each year during the time. Let's run a code, but here there is a problem. We have no function as reample. Actually, the resample is correct. It was a typo. So let's run a code again. PR annual will be available after a few moments. So the process is done, and let's make a print from annual precipitation data. Here you can see the annual precipitation based on millimeter calculated, and it is available with annual frequency 2010, 11 until 19. The next step, you can plot the yearly variation of precipitation. Let's import matplotlib.pyplot as PLT. This is a typical library that we use in the Python area for plotting the data and visualizing. So the PR annual dot plot x equals to longitude dimension, y equals to latitude dimension. The color map equals to, there are a lot of color map palettes in the Python language, but here I'm gonna use the blues. And then the time and temporal column should be defined another dimension as time, and also we want to have, as it is a multi-temporal data and multi-temporal map, we want to have actually multiple maps in each row. So for example, I'm gonna have 5 maps in each row, called wrap equals to 5 because I want to have 5 maps in each row. Robust equals to true. Let us to get rid of outliers. Let's run a code, and after a few moments here you will have a multi-temporal map that shows how annual precipitation data varies from 2010 to 2019. Darker blue region, higher precipitation, and vice versa. As you can see, in 2019 we have higher actually precipitation values in the northern and southern side of a study area. So, and the precipitation values ranges from 0 to 700 millimeter per year. So that varies from one region to another region. In this kind of time series analysis, you are doing the spatiotemporal analysis. You are getting insight about the temporal and spatial pattern for your region of interest. That gives you a lot of information about the areas covered by precipitation or the areas actually suffering from lack of enough precipitation data. The annual PR is ready. In the next step, I'm gonna calculate the annual temperature data. But as you can see, the temperature is available as temperature max and temperature min. We can get an average from these two bands and then get a single temperature data for each month and then convert it to annual frequency. It's very easy to do using X-ray and XE library. Okay, let's make a variable as temperature first. In the data set or DS variable, we want to calculate the average temperature for each month. Temperature min plus ds dot temperature max. Let's bring it or put it into parentheses as a numerator that is divided to 2, and then the whole of equation must be multiplied to 0.1. If you go to the data properties, you will find a scale factor as 0.5, 0.1 that is applied here. So, and we can also round the output in two integer values and then set a name for the output band that is the temperature here. Let's run the temperature variable, and after a few moments a single temperature or average temperature created for the period of time. Now as you can see, 120 temperature data calculated, and all but it has the actually the monthly frequency. The next step, I'm supposed to convert it from monthly to annual frequency, the annual average. So temperature annual equals to get the temperature data and resample it to annual frequency to the average through the time. So let's get a print from annual temperature data with degree Celsius values that you can see calculated the average for each year. Do the visualization through the plot. The temperature data, the annual temperature annual dot plot, x equals to longitude, y equals to latitude, and then the color map could be, for example, cool warm, robust equals to true, because we want to get rid of the outlier values to have a good contrast. Temporal variations defined through the time, and call wrap equals to 5 because I'm gonna have 5 maps in each row. Let's run a code, and then average temperature data will be ready here, and you can see the temperature variation for your region of interest. The blue region, lower temperature; the red region, the higher temperature, as you can see here. So in the next step, we wanna know actually how is the variation relationship between temperature and precipitation through these 10 years. So it is very easy. We can make a correlation map to understand how temperature and precipitation increases or decreases. For example, is there any direct or indirect relationship, or there is not a significant relationship between PR and temperature variations in this region? To answer this question, the correlation could be a beneficial statistical analysis that I'm going to show you here. The correlation map equals from XR, from X array library, we call the correlation function. So temperature annual and precipitation annual, based on temporal variation, we want to make a correlation map. Let's run this code and then correlation map gets ready. After a few moments, you will have a new array structure with latitude and longitude. This is a single correlation map that ranges from -1 to +1. So let's make a plot to make a better understanding about the relationship between these two variables and based on correlation. So correlation map dot plot x allows to x equals to longitude, y latitude, robust is true because we want to have a good contrast, and let's leave the color map as it is. And also we have no the temporal column here anymore because there is only one single correlation map according to the time series. And then let's run a code here, and after a few moments correlation map is created. The red region shows a direct relationship between precipitation and temperature, meaning that increasing temperature, increasing precipitation, or vice versa. Or white region or very light blue region shows there is no significant relationship or pattern between these two variables, and the negative relationship shows there is a vice versa behavior between these two parameters. For example, if in precipitation increases, the temperature decreases. Two different behavior actually have seen between these two parameters that is spatially distributed in different regions that could gives you insight about the spatio-temporal changes. I hope you like this tutorial, and then the code link is also available below this video on my YouTube channel. Feel free to reach me out and find the code and use this tutorial for your own study. And I'm asking you to share this tutorial with other members who are interested to remote sensing. Thank you for your attention.